Okay, hi everyone. I'm Jan, CEO of ChainsAtlas, and what we're doing is basically we enable a developer out of the Web2 space to quickly develop for a Web3 protocol to make the transition really smooth. Our tagline is basically we get your Web2 software into Web3 within hours or less. Why that is important and what all that means, we're gonna talk about in the presentation. But in essence, that's what we are doing. I myself had initially a tech background, studied some physics in between, went then back into IT, worked for a long time with big corporates in a consultancy, and last but not least, started my first product startup in 2017-18, which was in a industrial analytics field. And through a few circumstances, I fell into the blockchain space. I'm relatively new. I started that in 2021, and I did not come through the way of crypto and investment. It's probably not my forte, but through the angle of technology, through a project that we were running. Yeah, and we stumbled upon this problem, have been developing ever since, and now have our product release on the 25th of August. So everybody's invited to our big opening event on Bali during CoinFest. And I would love to talk about interoperability a little bit and why this is important and why we put so much work into that space. Good. In that sense, let me open my presentation and we can dive right in. So what is interoperability? Here's the official definition according to Oxford Dictionary. Interoperability, the ability of computer systems or software to exchange and make use of information. There's another definition, the ability of military equipment groups to operate in conjunction with each other. Let's not talk about that today. It's not really my expertise. So let's leave it out. But the ability of computer systems and software to exchange and make use of information. What would that translate into in a blockchain environment? There are, as you know, various blockchains out there. And in essence, it means that these blockchains have some form of interface with each other, that you can communicate with each other. There are three essential levels to interoperability, especially in a blockchain environment. There's interoperability of assets, interoperability of information, and interoperability of process. Interoperability of assets is what has been around for a while, probably the first form of interoperability. It basically means I'm able to move assets from one blockchain to another. What we're talking about here are bridging protocols. Something where you basically have token A and want to move that token A, or a certain amount of those tokens, to another blockchain. There are a group of those. There are a number of these protocols out there. I'm not going to name any specifically, but I'm sure most of you are familiar with it. I'm sure many have used it before. Why is that useful? It's useful because I'm able to use DeFi protocols on blockchain A, but also on blockchain B using the same assets, basically. So I maybe don't have the offering on blockchain A that I'm looking for, so I move the assets to blockchain B and have the DeFi protocol, make use of the DeFi protocol there. So basically, if I'm a protocol that develops on blockchain, it means, okay, I can use let's stick with the DeFi protocol that I developed for blockchain A and copy paste it basically to blockchain B, deploy it there, obviously have to do the necessary adjustments in terms of technology, but have the same protocol essentially in blockchain B, and can make the same offerings to user in blockchain B, and can move my assets around between blockchain A and blockchain B. So that's essentially what interoperability of assets means. A somewhat newer development is interoperability of information. What does that mean? It basically means, imagine you have a computer network and you send emails around, or you send instant messages around. The internet is basically a interoperability environment of various nodes that communicate with each other. It's a network, right? We can build the same between blockchains. So essentially what you're doing is you have the ability to move information of certain states, of certain transactions, of certain actions on blockchain A to blockchain B. What that means for you is you can basically build a software on blockchain A, a smart contract that then interacts with another piece of software on blockchain B. I can basically do certain operations on, let's say, Ethereum, because I want the perceived security of that blockchain, but realize it's too slow for other operations. So I run other operations on blockchain B. One of the newer chains, Solana, Near, you probably heard of all these chains, some smart contract platform. And I have the ability to basically outsource some computation on this other chain by informing that piece of software about what's happening on blockchain A, but have still all assets on blockchain A and make use of the security on that blockchain. So I have much more flexibility in how I build software among different chains. These are routing protocols mainly, and the chain links and layer zeros of the world. Last but not least, interoperability of process. That's where ChainsAtlas comes into place. That's basically what we are doing. What it means is I build a software, a smart contract environment that is built among different blockchains. We have a similar technology, and that's basically where this concept first came about in a traditional data center space, in a computing space, where we have various pieces of hardware and we create a virtualization environment which makes use of the resources of these different pieces of hardware, and you create your software and deploy it among these different resources. So it's basically a meta layer on which you create your software. So the advantage for you as a builder, as somebody that creates a protocol, obviously in that scenario, is you build one piece of software, and you can, out of that code base, then trigger certain actions on different blockchains. Or you don't even care on which blockchains you're running. You just use an optimizing algorithm, which then optimizes your runtime spread over different blockchains. That's a very recent development, and basically still in a subject to research, as it's named so nicely. We will release this capability within this year. It's not a capability that will be right in the first version of what we are doing, but it will be a capability that will be coming quite quickly after our product launch. So these are the three essential levels of interoperability. To put a little bit into context what we are talking about here. Why is the whole thing really important? I mentioned already data centers, in which you have this virtualization layer on which you can then deploy software. Before that was the case, I would have to choose one server with a certain capacity on which I then can deploy what I want to do. Now that we look into data centers, we talk about thousands of computers, of servers. Now you'd think, okay, there can't be that many blockchains. Why would I really need that? Maybe you want to think twice. The smart contract space, and this is what we are looking at here. This is taken from, I think CoinMarketCap, might be CoinGecko, but one of the listing websites of blockchain protocols and coins and tokens. And these are only smart contract platforms, or I think it's layer ones, general. Layer ones meaning platforms like Ethereum, like Solana, like these protocols that you certainly heard of, on which smart contracts are built, on which decentralized apps are built. There are more than 150 of those. And good luck in choosing the right one if you want to build your own protocol. I mean, look at this. This is enormous. So in essence, you have a very similar situation. There are differences, obviously. Each of these protocols has its own certain unique capabilities, its own certain unique strengths and weaknesses. So there is obviously a component where it makes sense to optimize what you are doing according to where it runs on. There is the topic of decentralization in blockchain. I don't want to go too deep into what that actually means. That's probably a subject on its own. But fair enough to say, not all blockchains are made equal, and not all of them are at the same level of decentralization. All of them have the same speed available. Not all of them have the same safety available. There are certain aspects you want to look into, and you can distribute your development accordingly. But the point I want to make is there is an abundance of blockchains out there, and this is by far not the end to the story. There are a lot of not yet listed blockchains out there, and there is a bunch of them in development. So as I said, 150 plus smart contract platforms. All of them are different to a degree. All of them also represent potentially a different development environment. There is something like a standard EVM, basically the environment of the Ethereum blockchain, on which a lot of blockchains adopted. So you can basically use code that is written in Solidity, the coding language used for to develop those smart contracts on Ethereum, and you can develop for other blockchains. You can basically copy paste your source code and deploy it somewhere else. But a lot of other chains are non-EVM. They have their own protocols, which is unique. A lot of the newer blockchains actually develop their own new coding language, which is definitely not easy for everybody to adapt, because it means you need to have a developer base which is capable of developing in that language, or you need to retrain. So why is that an issue? Let's look into the adoption of these blockchains from a developer point of view. How many people actually do develop for a blockchain, right? And for this particular blockchain. That's a question you want to ask yourself. You just learned all are slightly different. It's not necessarily trivial to develop for blockchain A and then go ahead and do the same for blockchain B, because it's a different coding language potentially. It's a different environment. You want to know the ins and outs of that blockchain. So looking at this picture, what we are seeing is the distribution of developers in certain languages. Far ahead, if you look at it, here is Ethereum, which has currently, this is data from Electric Capital, a survey from the end of last year, publicly available, feel free to download it. Quite interesting insights. So at the end of last year, you'd be looking at something between 5,500 developers on Ethereum. So on the x-axis, you see the developers in 2021, and the y-axis projected for 2022. By far, this is the most developers in any community. We have Polkadot following in a distant second place, where you'd look at 2,000 developers. And if you zoom in, then we just saw this list here, right? All these different blockchains on which you could theoretically develop your decentralized application. If you zoom in a little bit into that little cluster down at the bottom, and you'll see, okay, even there, very few even make it to 100 developers. Not even that many make it to 50. And the vast majority is somewhere down here in this tiny cluster with where we count in the tens, maybe 20s. So it's definitely not that easy to onboard new developers for the reason we just saw, but there is a huge amount of computational resources available for you to develop on if you'd be able to really tap into that interoperability and build among different blockchains and truly decentralized apps, what you really care for, right? And not just for becoming member of one specific particular ecosystem. But it's just to demonstrate how fragmented the market at the moment is and why interoperability becomes so important. Imagine you have a gaming protocol and you might be able to land a grant from one of the smaller blockchains. You maybe find another 10 developers developing there at the moment. You need all these resources, you onboard there. You might find out, okay, the horse I bet on is not performing that well. Some of these blockchains are not doing that great. Maybe there's a management issue or whatever the problem is. You might want to move to another chain. So that is a challenge. Another reason why interoperability is so important, to be able to facilitate that much more smoothly, like you would now from going from one cloud environment to another one. Basically, you'd still go deploy the same software. It's just a different environment. So that process has become is much easier, and we talk about like what a few, probably you can count on your own hand what are the big cloud environments you'd ever deploy on, right? That's different in blockchain. So in general, if you want to build on blockchain, even if you take this whole spectrum of different blockchain we just talked about, you talk about grand total of 25,000, according to the same study, of 25,000 developers, monthly active developers in the whole blockchain space. And if you think about that, has been responsible for a 1 trillion market cap not too long ago. I think right now it hovers somewhere in hundreds of billions, but it's a lot of money. And pretty much every big corporate would die for such a ratio. 25,000 people being responsible for this kind of value. Right? But it also means that pool of developers is very limited. And the fascinating thing of this is just to showcase how active that market is, even when the prices, the price action went down by 70-80% last year in the deep bear market. The number of developers actually grew by 8%. Just to show how much activity is happening, right, across all blockchains. But yeah, it's 25,000 active developers on a monthly basis. That's not a lot, not a big pool, especially if you look at 150 plus different platforms where they develop on. Hence, obviously, interoperability has become more important. And the number of developers that have capabilities to deploy to different blockchains and have done so over the last years has steadily been increasing. So starting in 2021, when a lot of these newer layer ones and smart contract platforms came online, this number has been growing ever since on a steady pace. But if you look at the y-axis here, that chain count, even now, you're looking at 1.2 1.3, if you're generous, 1.3 different platforms that on average a developer would develop for, out of, again, 150 plus. So we are definitely not where we want to be in terms of interoperability. And one of the reasons is I have to develop a unique code base for each of these blockchains. As a developer, I would have to be able to know different languages. It's not necessarily trivial. And if you zoom in into this a little bit, there have been almost 1.2 million commits of software by people that develop for exactly one blockchain. And the next one, when we look at people that develop for two blockchains, it's barely registering. Right? It's maybe 10,000. I don't know. It's a very low number compared. So we definitely still have a lot of fragmentation and isolation in the blockchain market. And interoperability, even though everybody talks about it, is barely existent in the market as it is right now. So let's compare this a little bit with a more traditional environment. So if you develop software for traditional software, let's say Web 2, you also have a bunch of coding languages that are available to you. The difference is each of those has a way bigger community. JavaScript alone is, I think, 15, 16 million developers that are actively developing JavaScript on a monthly, probably daily basis. Compare that to those 25,000 all over blockchain. So there's still a long way to go compared to traditional software. Now let's imagine you'd be able to tap into that pool and get those developers to develop for blockchain without having to relearn a new language and all these kind of things. And once they do so, don't have to specifically develop for only one blockchain, but can deploy to any blockchain. That level 3 interoperability, remember? So basically what that would mean, I take JavaScript, I'm one of those 15 million. These 3, by the way, are the first languages that we will be onboarding in our protocol. And we will enable them to do just that. So if you're a JavaScript developer, if you're a Python developer, if you're a C developer, you can develop a smart contract and deploy it to pretty much any blockchain that we are onboarding. And there will be basically most of those 150 plus we will be onboarding over time, over the next few months. We're starting with all EVM chains, which already is a bunch, and then we're adding new ones. So what you have there is basically what we talked about earlier, interoperability of process, of software. You can build software in a singular way, in a unified way, using the languages you used to, and basically deploy them to any blockchain. And in a few months' time, you can deploy them among different blockchains. You just tell an orchestration solution, okay, I have certain criteria how I want to develop this. You make use of these different blockchains, blockchain A, B, C, D, and then there's an optimization algorithm which calculates, okay, where do I put the computation at a given point in time? So all that abstraction, all that having to understand all these blockchains will go away. It makes it much easier to actually create and focus on creating killer products as opposed to having to focus on learning new languages, learning how new blockchains work. And having these things communicate with each other right away. So that's why interoperability is so important. And this is the only way, if you ask me personally, obviously I'm slightly biased, but there's a reason why interoperability is such a big topic right now. That's the only way to actually get to mass adoption. Because if you stay within this fragmented market, it's a big obstacle for new developers to come in, which is then a big obstacle for new protocols to develop. And in our perspective, there are two big things that prevent mass adoption at the moment from two angles. One on the development side that I just talked about extensively, and obviously on the user side to make things really easy to use, which is, as we probably all know, not necessarily the case in blockchain at the moment. I need to understand how a wallet works. So that is the other aspect, which a lot of companies are also tackling. Some of our partners do. We are on that developer side where we want to enable your friendly developer around the corner, or somewhere on Bali that has been developing Web2 protocols for the last 5 years, is capable of developing amazing solutions, but just doesn't want to bother with learning how blockchains specifically work and what are the ins and outs. They just want to develop something really cool. So with these 3 languages alone, you'd go from 25,000 to 35.2 million developers that are potentially able to develop really cool decentralized applications. May that be play-to-earn games, may that be DeFi protocols, may that be something completely new that we don't even imagine right now. So what did I talk about just now, right? What's the difference? Why is it so much easier to develop in that way? Basically, right now, what you have is you have maybe a specialist for blockchain A, in this case, we use the symbol of Ethereum, specialist for blockchain B, in this case, Solana, and then another one for chain X, Y, Z. And they all have to individually develop code for these blockchains, which might even do the very same thing, but it's still a development effort, right? Because I need to tailor make it to that blockchain. The transition we are seeing in the future is that people will be able to develop one code base and then develop it and deploy it, to different blockchains. Go ahead and develop in a language that you're familiar with, JavaScript, C, whatever it is. Develop a really cool, amazing product and don't really bother which ecosystem it has to be on. And try things out. Experiment with blockchain A, experiment with blockchain B. These things become feasible now, because before this, it would probably be cost prohibitive to even attempt that, because you would have to redevelop the code, you would have to get the right developers, which are usually not cheap, because again, scarcity of people that actually do it. And then try it out. So it's a huge capital expense for which it might be not feasible. Right now, it's developing once, deploy it to A, deploy it to B, overhead of a few minutes and a bit of traffic. So basically, and that is again what we are working on, and others obviously also working on, is the goal is to combine the power of multiple chains. And if you think back again on those 3 levels of interoperability, they obviously go hand in hand. Interoperability of process, what we are working on, what I have been describing now exhaustively, isn't feasible and isn't thinkable without interoperability of information. Because process, in essence, is also information. Right? So the state of my software right now, I need to communicate from blockchain A to blockchain B to make it available in blockchain B. And then, again, especially in the blockchain space, assets are what it's all about, right? The coin, the tokens, the NFTs. If I'm not capable of moving those from blockchain A to blockchain B, or at least routing that information, what kind of token I'm looking at, or what kind of contract I'm looking at, what kind of other software I want to interact with, maybe on a different chain, from blockchain B to A back. If I'm not capable of having that back and forth, that information exchange of the underlying assets my DeFi protocol, let's say, is all about, then the whole information transfer and process transfer doesn't really make sense for me. It's null and void, because it can't really interact with what a blockchain is all about, which are the assets on the blockchain, tokens, NFTs, other smart contracts, other software. So again, this all goes hand in hand. It's not necessarily a competition between these solutions. As always, I think everybody achieves the best results by cooperating and working together. So one needs the other. And what our big goal is to basically build a network of blockchains, a cloud of blockchains, where all these blockchains basically interact with each other and processes, dApps on those blockchains interact with each other. And we basically taking a step back, thinking about why are we doing all this? Where do we come from? We want to cut out the middlemen, right? We want to have a decentralized environment where we can really trust that nobody plays around with what we are doing there. We want to have an environment where self-custody is possible due to that decentralization effect, where we are sure that we can take possession of certain things, let's say in-game NFTs, where I really have ownership of my items that I win in the game. I'm not a big gamer, but or DeFi protocols where I have actual ownership of the assets that are put there, that the DeFi protocol then works with to create additional value. That is what it's all about, not to be part of a specific ecosystem. That, if you think about it, might even be a step back into the old world where I had certain players in the game taking control of certain actions, where I had to trust them. So if I really think in that way, then I just want to develop a decentralized application and want to make use of as much resources as I possibly can and build the best thing I possibly can. And in that sense, the whole big goal should be to let these different protocols talk to each other, enable to develop solutions that are capable of running on, let's call it a substrate of different environments. And you can focus as a developer on building that really amazing product, that really amazing decentralized application, the best game you can, the best fintech product you can. That's what you want to do, right? If you build a product like that. So that is why interoperability is so important. Now, if you liked this topic, if you have maybe more questions, feel free to contact me. Also, feel free to sign up if you're a developer or a company that develops for blockchain, wants to develop for blockchain. If you're a Web3 protocol, feel free to sign up for early access on our website. You'll find the link here. Feel free to contact me if you have any questions. Always happy to talk about this topic. You saw I'm quite passionate about it, not only because we are building this product, this offering, but because it is a very fascinating and very vibrant environment at the moment. And we are, as you saw, in a very early stage of development. So there's a lot of exciting stuff going on. And I can only encourage you to ask questions, to learn more about it, and find your own path in the space. Thank you very much. Yeah, basically the isolation of each protocol. Each of these protocols has its own architecture. Some have emulators that work in a way that you can run the same code that you have developed for another chain on them. We talked about EVM compatibility. That's basically that. People emulate an environment like Ethereum offers, so you can use code that you develop for Ethereum and deploy it on their blockchain. But essentially, they all have a different architecture, and it's not necessarily trivial to make them communicate with each other. for a developer, from a user perspective, like user in a sense of, I want to develop something there, I want to use this blockchain to develop something. The big challenge is that most of these blockchains use different languages that I have to be familiar with. All of these blockchains have different capabilities that I need to be familiar with. They have different TPS, transactions per second, so speed, basically how much computation can I do on the chain before I run into limits. They have different consensus mechanisms, again, something that could fill a whole session, but they have different implications on the way I develop and how secure that blockchain basically is. The other thing is how decentralized is the blockchain really, or do I have a third player that controls most of the blockchain? Do I want this? So there's a lot of considerations you have to make to actually build for blockchain environment, and that prevents interoperability in a way that it's already a big task to learn how to develop for one blockchain, and then being asked to develop for two and make these two things to talk to each other is actually a challenge. And most startups don't have the time, capital, and human resources to do that, frankly. Again, it's a question of what you want to do. I showed the 3 levels of interoperability. So if you just want to move assets around, you're probably fine with the bridging protocol. Being aware that what's happening there is actually fundamentally, there's just a big pool. You put some from place 1 into it, and they then swap this with the same thing on another chain and put it there. So there's an intermediary. So you need to trust that bridge. If that bridge is, and we've seen a lot of instances where that unfortunately happened, is exploitable, and the liquidity is drained of that bridge. So there is not enough of that basically mass of these tokens on both sides available. You cannot bridge anymore, essentially. And you might actually lose the assets you try to bridge. So they are unfortunately quite vulnerable, and we've seen many instances where bridges were attacked, which then again had also a lot of impact on the underlying blockchains that use these bridges. But yeah, essentially, if you just want to move assets around, that's the technology you want to look at. If you want to send information from your solution in blockchain A to your solution in blockchain B, layer 0, chain link, routing protocols. There are many others as well. I don't want to highlight one particularly one. Those are probably the hottest in the space at the moment. But in essence, they all do the same. They enable things that happen on blockchain A, so basically transactions that happen on blockchain A, to communicate that information to blockchain B and tell blockchain B, look, this is what happened there. Make with it what you want. And then you have another solution on that blockchain B, which reads that information and does with it what you want. So that's essentially the other way of tackling the problem. And then what I'm labeled as interoperability of process, where you have all this abstracted away and you basically just develop one solution that then gets optimally distributed over different blockchains. That is level 3, which currently is supported by what we are building. So without any further promotions here, but that's at the moment quite unique. Probably won't be forever, but at the moment that's our offering and our unique selling points. Again, you need to look into what kind of interoperability, like moving assets around. That's been common for a few years. Most DeFi protocols enable that for you. That's been there. It's been exploited several times, as I mentioned, but it's around. So that's successfully proven to work. Like ID in the sense of digital ID on the blockchain. I'm not familiar with any protocol that is really successfully and widespread doing that, but several work on it, and it should be technically feasible. Information exchange between blockchains, it's a relatively new space, but there are some trading protocols which have achieved this, which basically communicate, and that's where the initial idea of that form of interoperability came about. Blockchain specific information between each other. So there are decentralized exchanges, decentralized trading protocols that are capable of reading information from other chains and direct price information mainly, and use that information on their own chain. Right? That's what Chainlink, for example, became really big with. But true interoperability, as we've seen also in the statistics earlier, honestly, I've not seen anybody really having that achieved and being applied on actively by and used by a lot of users. I wouldn't know any protocol that's at that stage yet.